the creator or the self-created one is created by commandment, declaration, or proclamation. Spoke is song or music, a word, an utterance, or a breath create all. You might have heard these sayings many times. They all reference to sound. So the common denominator in all these sayings is a sound. Fellow Toastmasters, most welcoming guests. Sound is created, the universe is created from sound. So if we can understand how the sound works, we can understand how the universe works. So in this presentation today, I'm going to talk about sound. So sound is a compression and expansion of a fluid. So it can be any fluid, it can be water, it can be air, or any type of fluid. So sound is compression and expansion of a fluid. So as shown on the diagram here, we have on the top, we have compression wave and transverse wave. So sound is different than light wave. So light waves are a transversal that moves up and down, and also water waves moves up and down, and sound waves move side to side as compression and expansions. It has set frequency and set wavelength. So if I have one compression and expansion, that's one wavelength. And for the frequency, if we make these compression and expansions faster, that's a fast frequency. If we move it slowly, that's a slow frequency. And also there's a variation in pressure for the sound. And that is directly proportional to intensity. So variation in pressure requires for a detection. So that's how we detect sound. For different time of arrival of the sound and intensity difference. So difference variation in the pressure. So today I'm going to talk about three different examples. First one going to be related to animals, and then we're going to talk about material. So how do we hear sound? So let's take a look at human first. So we have a separation between our ear, and that makes us to detect sound. So two parameters are important to detect sound. One is the time of arrival, and second one is variation in pressure or intensity. So we can hear the sound if we can detect those two things, time of arrival and intensity variation. And we have a special detector called ear, and that can detect sound. So when the sound intersects our ear, we have a pinna outside, and it can trap the sound energy and send it to the eardrum. And eardrum moves back and forth and absorbs that energy. And then we have a tiny bones here in the ear, and that tiny bones transfer that absorbed energy from the pinna to the cochlea. The cochlea is located here. That's the snail-shaped organ, and it has a fluid inside. And it can convert sound energy to electrical energy and send that electrical impulses to our brain. And brain interprets that as a sound. So that's for the human detection. Now we can look at the bigger animals like elephant. Elephant is the largest animal in the world, and it has a way bigger separation for ear. And those animals can detect even low frequency sound. So one of my professors told me a story in the class, and he said they were doing some experiment in Africa for a sound detection experiment, and they saw a herd of animals running, elephants running across them. And they wonder why there were like so many animals, 20 of them running on one direction. And then they noticed that they all stopped at one location, and there was a female elephant. And they started recording those sounds, what was the cause of running those elephants in one direction. And they find that female animal was making a mating sound, and all the male elephants are running toward that female elephant. And they start recording those, and they analyze on the computer, and they see those are the really mating sounds. So animals like elephants, they can hear very low frequency sounds that human cannot hear. So animals like elephants, they can hear from 1 to 20 hertz sounds. Now that was a bigger animal. Now let's talk about the smaller insects, like a fly. And they don't have much separation between the ears. So very small separation. And how these flies can detect sound? They can detect that pressure variation that quickly because the separation is very small. So this picture here, there's a cricket on the bottom and fly sitting on the top. So as I mentioned before, I think in this one of my speech, I set up my alarm to go for a run in the morning. And the alarm went off at 5 o'clock in the morning. And I woke up and I shut the alarm off and went back to sleep again, and I was dreaming. I was running in my dream and it was dark outside. And I noticed there's a cricket making sound. And then I saw a fly that responded to that sound and sat on that cricket, and the sound stopped. So what was happening there? That cricket was making a mating sound, and that fly responded to that mating sound and sat on the cricket and laid the eggs. And that's how the reproduction for that fly continues. So this fly can detect sound of a cricket. So I was curious in my dream. I catch the fly and brought it home and chopped the head off and looked at the ears. So how the ear look like for the fly? How can this fly can detect sound? So what I find, this fly has a mechanical system to detect sound. It's not acoustical like we have two ears. It has also two ears. But the difference between this fly will be number 3 on the top. There 1 and 2 are ears, and number 3 is a mechanical linkage between those two ears. And that mechanical linkage makes that fly to detect sound. So if the sound is coming from this direction, and the ear goes like this, the mechanical linkage, the fly knows that the sound coming from the front. If it's coming from the behind, the ear goes like this, and the mechanical linkage goes like this, and the fly knows the air is coming from the behind, sound coming from the behind. And if it's like this, it's a rocking mode, and it tells the fly that the sound is coming from this direction, and it can also detect from the other direction depending on the mechanical motion of that linkage. So that's how the fly works. Now that was animals, and we all know the animal, human, elephants, flies, we all can hear. But what about the objects? Is there any object can hear the sound? But if the creator, the self-created one, created the universe, and sound, the universe is created from the sound, then everything should be able to hear the sound. So is that anything can hear the sound? So here's my phone. Google. It opened the Google. So yes, anything can hear the sound. Even the bananas, basketball, oranges, they all can hear the sound. So we need to find out how they can hear the sound. So in this phone here, they have a microphone. That's a micro electromechanical system, very small sensor. that can hear the sound. And based on this fly, we can make the sensor. The fly has 2 ears. We can make the small sensor that has 2 wings and connect them as a mechanical linkage in the middle. So from using semiconductor material, we can make these devices as a microphone to detect sound. And the process to make that, we use silicon oxide insulator process to make these small sensors. So in the starting, we have on the red, we have silicon on the top, the black one is oxide, and in blue, we have substrate here. So substrate is a bigger part that's used to handle the material, and then we put the oxide and silicon on the top. So that's the starting point for our sensor. And then we can do the doping. So doping is required because there's insulators and there's a conductors. Conductor that conduct electricity and insulators that does not conduct electricity. So to make the middle, we make a semiconductors. So we need to do dope these materials with different elements to create conductivity in the material. So we can dope the silicon with the phosphorus or boron to change the conductivity of the material. And then once we dope this material, we have the right material that has a certain conductivity, and now we have to create a pattern on the top of these materials to create devices or mechanical systems. To make the device we can do photolithography. So here we have a light source as a UV light. Here we have mask to create the pattern, and we shine the light on the substrate or on the silicon, and it creates the pattern. So that's how we create our devices. So finally, the device will look like this. The ear wings are moving back and forth with the sound. When the sound hits these wings, it just start moving back and forth, and we can detect the sound from the movements. So in conclusion, we looked at animals, we looked at the objects, everything can hear the sound. The universe is created from sound, and that's important to understand how the sound works, to understand the universe.
Thank you, Carl, fellow Toastmasters and guests. Parminder did a great job here on project number 3 of the technical presentation manual on sound detection. I think we can rejoice on knowing a lot about sound detection. The purpose in your manual is to do a presentation for a non-technical audience. And I think in many ways you handled that quite well, because you gave good examples from going from the human sound detection to the elephant, showing that big separation in space. That was really important. And then the example of the cricket and the fly. I thought that was really good. So for the non-technical people here, I think we could all relate to that. When you got into the SOI process, I started to gloss over it. And I'm just being honest on that. So it's not that it's not important to you. Your passion comes through. It means so much to you, and it's very apparent in your voice, everything. But when you are talking to people that don't really get it all, it might be a little much. You may have wanted to shorten that and not maybe even included that part of it, or do it in 2 presentations. It was interesting. You tried to avoid really heavy technical jargon, so that was good for the most part. And most of it was easy to understand because of your good examples. I think, though, that sometimes a couple of the slides might have been a little blurry. Maybe those weren't the best ones to use, the one with the objects that for the sound detection. And I think on the conclusion might have been just a tad bit weak. I don't know. I know you circled back into how you did your opening, and your opening was very good as you talked about the universe is created from sound. That was a powerful statement to make. But in the close, maybe you should have added, or could have added a little bit more to that to make it have a little more punch. A little more eye contact with the audience is really important. You did not totally rely on your slides, which is great because you weren't looking at them constantly or anything like that. I did think that the fly pictures were really, really good too, just demonstrating all of that, because that was hard to explain, especially that they're not acoustic and going from flexible and bending to the rocking mode. That was well done. So overall, it was a really good, solid speech, but you just still just be aware of your audience for that. Excellent, well done.